disorders, it is divided into two. One is Mendelian disorder, the other one is the chromosomal disorder. I told you Mendelian disorder, if there is any change within a particular gene, it is about chromosomal disorder. If there is any change within the chromosomal number. Understood? Okay, then we call that the chromosomal disorder. So how come we have learned about the ploidy, right? I have taught you about ploidy. So what is that? First, let us recollect the term ploidy, what we have learned. Okay, this ploidy is divided into two normally. One is called as euploidy and the other one is called aneuploidy. So here in euploidy, you have from start. Euploidy talks about the n number of chromosomes, PPM. So here you have example monoploidy. So what is that mono? Only one N, single N. Okay, then if you give example diploidy. Diploidy is human being, 2N number of chromosomes. Okay, right. Likewise, I have taught you about another term, polyploidy. What is polyploidy? 3N, 4N, 5N, it goes on, right? So normally after the 2N, if it is 3N, triploidy. If it is 4N, tetraploidy. If it is 5N, pentaploidy. If it is 6N, hexaploidy. So it goes on. So in all together, we use the term polyploidy. Have you understood? So this is euploidy. Okay. And next one, when you talk about this aneuploidy. Okay. What is this aneuploidy? I write here. Okay. Under aneuploidy, you have two divisions. One is called as hypoploidy, and the other one is called as hyperploidy. So what is the difference between this euploidy and aneuploidy is, euploidy is always mentioned in terms of n number of chromosomes. Okay, so monoploidy is n. Then diploidy, it is 2n, 12 plus n. Triploidy, again 1n. Again tetraploidy, again. So it goes on like this, plus. Right, so n number of chromosomes. What is the term of haploid? Be clear. So hypoploidy, under hypoploidy, there are two types. One is called as monosomy. Okay, the other one is called as nullisomy. One is called as monosomy, the other one is called as nullisomy. What is that monosomy? See here, 2n, example 2n. Okay, what is that 2n? 46 in human, I'm giving you example. So 2n minus 1. 2n minus 1, only one chromosome is deleted. Example, if this 2n is 46. So 46 minus 1 will become 45. So only one chromosome deleted. Okay, if there is any change within that one chromosome, then it becomes 45. Then you call it as monosomy. Mono means one. Remember like that. 2n minus 1 is monosomy. Have you understood? 2n minus 1 is what? Monosomy. Right? Here, I'll tell you what is an example. I'm going to teach you. Next, nullisomy. What is nullisomy? 2n minus 2. 2n minus 2. If it is 46 minus 2, it will become 44. So remember, 2 minus 2 is 0. Null set, you will say no empty set, null set. So 2 minus 2 is 0. Remember like that. So remember the term nullisomy. 2 minus 2. So here, in this case, the individual will not survive. Will not survive. Can you understand? So hypo means decreasing. Hypo means decreasing. So remember, so hypo means we are going to minus 2n minus 1. 2n minus 2, it is decreasing. Okay, what about hyper? Hyper means more. So here 2n plus 1 and 2n plus 2. So what is this 2n plus 1? Here you are going to minus and you are going to say mono. Here it is added 2 plus 1, 3. Trisomy. So trisomy means 2n plus 1. Tetrasomy. Tetrasomy means 2n plus 2. 2 plus 2. Have you understood? Chromosome. Whereas aneuploidy, it is talking only about 1 or 2 chromosomes. Either it is deleted 1 chromosome, then you call it as monosomy. If it is 2 chromosomes are deleted, then you call it as nullisomy. Here in hyper, if 1 chromosome is added due to mutation, then you call it as trisomy. If 2 chromosomes are added, then you call this to be tetrasomy. So tetrasomy, very good example, you can see apple, pear. It is not seen in human beings, okay? So here it is seen mostly in apple and pear. Can you understand? Here I told nullisomy, they will not survive. Here apple and pear. These two examples I'll give you when I teach you. Okay, understood? Now, here this aneuploidy, when it is caused, why does aneuploidy occur? chromosomal disorders you're talking, right? So how is the chromosome separated? Okay, meiosis, mitosis, we learned, right? Cell division. So mitosis is multiplication division. Meiosis is reduction division. Reduction division. So what happens here? The testis produces sperms. Right? Okay. So if 46 number of chromosomes are present, when it produces sperms, it becomes 23. So what are those stages takes place in cell division? You have prophase, metaphase, anaphase, and telophase. This takes place in cell division. Prophase, metaphase, anaphase, and telophase. So what happens here? When does this aneuploidy occur? When does this chromosomal disorder occur? It is due to non-disjunction of chromosomes. To use the term non-disjunction, it is very important. It is very important term, non-disjunction of chromosomes. So this chromosomal disorders can be seen both in the autosomes and the allosomes. So what are autosomes? 44 are called as autosomes. And here XX or it will be XY. So these two are called as what? Allosomes, and this is called as what? Autosomes. So these are called as autosomes, and these are called as allosomes or sex chromosomes. Be clear with this. Be clear with this concept first. Okay. Now, I have told you this aneuploidy, due to this non-disjunction of chromosomes, there may be change in this autosomes alone, or there may be change in the allosomes also. What are allosomes which represent the sex character, whether male or a female? What are autosomes which represent your body characters? Then you call that to be autosomes. Clear? Okay. So now, first example, what is given in your textbook is about Down syndrome. Down syndrome. Clear? There is a change in the 21st pair. See here? So I told you, this is first pair, this is second pair, it goes, right? So when you come to 21st pair, so example, if you take this is the 21st pair, due to non-disjunction of chromosomes, here one more is added, 3. So you call this to be trisomy of 21. Trisomy of 21 or 21st trisomy. So which is 3 in number? 21st chromosome is 3 in number. Can you understand? So there is an additional copy of 21st chromosome. So this disorder, it was first described by a person called as Langdon Down. Down, you know, right? D-O-W-N. Okay. But here, Langdon Down in the year. Langdon Down in the year 1866. That is why this disorder, it is considered to be Down syndrome. But the name of the person who has found out is, these individuals, they are called as Mongoloid idiots. They call them as Mongoloid idiots or Mongolism. Mongoloid idiots. Okay, all these are additional names what is given, right? Okay. Now, what will be the symptom in case if the person is affected by this Down syndrome? You would have said mentally retarded. Mental development will be retarded, mental retardation. Can you understand? Physical, psychomotor, mental, everything, the development will be suppressed, retarded, usage of retarded. Okay, and when you see, you call that to be Faruta, partially opened mouth. And the palm trees. You have this, right? So here one will be missing normal. Degrees what you have. Friends, right? So here it will be missing. So that type of syndrome is seen in this case. So what is Down syndrome? It affects the autosome. There is a change in the autosomal number. Don't get confused. That one you have to be very clear. And 21st trisomy. So there are many points here. I told you Mongolism, Mongoloid idiots, okay, trisomy of 21 or trisomy 21 or 21st trisomy, anything. Everything represents the Down syndrome. Now you give me this, you connect with that aneuploidy what I told you. Here it should be now 44, 45, 46. So normal human being will have 46 only. But here, this one more chromosome is added. So it becomes 47. So what is the number here in this individual? It has become 47. So the chromosomal number is 47. Can you understand what am I telling now? So this is what 2n plus 1. So what is this condition called as? What did I tell you? Hyperploidy, increasing. One more chromosome has increased. Additional copy of one more chromosome. Change in the sex chromosome. So what about change? What is that? Here you'll be studying about two examples. One is the Klinefelter syndrome. The other one is the Turner syndrome. Klinefelter syndrome. The other one is the Turner syndrome. It is only the name of the person who has described it. Okay, right? So here in Klinefelter syndrome, if you see, this normally what is the number of what is the representation? But here, Klinefelter syndrome, it will be 47, like Down syndrome. But here we are talking about the change in the allosome, right? So what is the chromosome? 44. There is no disturbance in 44, right? But there is an additional copy. What is that? Normally in male. This is normal male. What happened? One more X chromosome is added. So X talks about the feminine character, right? So what happens here? The male, the normal male will not be a normal male. As here, one more X chromosome is added. Now, this person will have 47 number of chromosomes. Can you understand now where is the one more chromosome added? Here, the sex chromosome should be 2 only. But here, one more X chromosome is added due to non-disjunction of chromosome. Additional copy of X chromosome is there. So, this is a genetic disorder. What you have to understand here. Okay, so this individual is not a normal male. So, what will happen? Normal male means overall masculine. Masculine, feminine, internal, right? So gender. So masculine development will be there. Male development. Be clear the terms, what you have to understand and learn. But here, what will happen? Due to this X chromosome, the feminine characters will be seen in the male. The person will be a male, but male characters will not be expressed, but female characters will be expressed. Feminine character is there. So what is that feminine character? Breast development will be there in the male. Mammary gland development will be there in the male. In that case, here you call that as gynecomastia. You have to be very clear because this question is asked in many, NCERT question papers. Okay, gynecomastia. So what is gynecomastia? Breast will be enlarged. Mammary gland will be enlarged. Okay, clear? And then the overall masculine development will be suppressed. Male characters will not be developed properly. Right? In that case, okay, you call that development to be sterile because the male will not be able to produce the sperms properly. Sterile, what is that sterile? We have learned. Isn't it not? They will not be able to produce the egg bonds. Individuals will be sterile. Okay. Now, what is Turner syndrome? The same way, there is change here. What is that? Here. Okay. One chromosome is lost. So it will be mentioned as X mode. 44 plus only one will be there. Klinefelters, what did we see? One more extra. So Klinefelters also 47. Even that also come under trisomy. So Down syndrome come under trisomy. Klinefelter syndrome also come under trisomy. But come here, Turner syndrome. What happens? It should be 46. But here, instead of 46, what is there? Minus 1. So it becomes 45. So it comes under what example? Monosomy. 2n minus 1. So, Turner syndrome is an example for monosomy. Here, it is also due to what non-disjunction of chromosome? Due to absence of one X chromosome. So, if it is X, she will be a normal female. But as one X chromosome is deleted, the female is abnormal. And the ovary will not be able to develop properly. In that case, okay, here it becomes 45. You call that to be rudimentary ovary. Very important term, what is given in your textbook. This term will be given in your textbook. Don't forget rudimentary ovaries, which is not well developed. And secondary sexual characters also will be lacking. What are those secondary sexual characters? Pubertal stage, right? Growth development, then hair development, right? Then hormonal development, then menstrual cycle. So everything there will be a lack of these secondary sexual characters in such kind of females.
Thank you.